Hello, everybody. Welcome back to the Doctors In podcast. I'm your host, Dr. Nadia Saba, president and founder of Dr. Greenhouse. Today's interview is part of our special series, What Plants Crave from STEM, where I'm interviewing equipment providers, engineers, and designers about the unique technological needs for growing crops indoors and in greenhouses. My guest today is Craig Burg, Vice President of Engineering at Desert Aire, an HVAC company that until recently was best known for their specialty HVAC equipment serving indoor pool environments. Today, they are well known in the indoor agriculture space as one of the few HVAC equipment providers who have geared their system operations, controls, and inner gears to better serve indoor plant environments. As Vice President of Engineering, Craig is in charge of product research and development, product testing, and custom engineering projects. I met Craig about 4 or 5 years ago after I first started Dr. Greenhouse, when Desert Aire invited me up to their factory in Wisconsin to give a guest lecture to their technical sales team about the unique needs of indoor farms. They were way ahead of their time. Since then, we've worked together on the new standard HVAC for indoor plant environments without sunlight, a standard that was co-developed by ASABE and ASHRAE, and we serve on several technical committees together at ASHRAE. In case you hadn't guessed, one of his HVAC specialties lies in dehumidification, and I'm pretty sure that's going to be the main focus of our discussion today. Craig, it's great to have you on the What Plants Crave podcast. I'm really excited to geek out with you about HVAC and take a deep dive into humidity control and why it's such a big challenge for indoor plant environments.
Yeah, thank you, Nadia. It's great to be here. And yes, I'll say, I'm sure we're going to geek out today a little bit. You'll have to stop me. I often slip into thermodynamics, psychometrics, refrigeration system cycles and details. It's really what I deal with every day and I'm well versed in. I do also feel I know these applications very well, but I have a tendency to think about how the HVAC systems react to the loads and the environment and so on and so forth. So you'll be my backstop. And when I get into compressor superheat or liquid subcooling, you'll pull me back, I'm sure.
I don't know if I will, because I want to know all about that as well. So, Craig, tell me, how did you first get interested in HVAC and the world of dehumidification?
That's a great question. I'm going to say no kid grows up dreaming of becoming an HVAC system designer. If your kid does, maybe you should go get them checked a little bit, perhaps. But that said, no, it's when I was going to school, like many kids, I wanted to have that dream job of something like an engine and powertrain developer for one of, I guess I'll age myself here, right? One of the big three, right? One of the automotive people, and this idea about the engines and the cycles that go with engines was really interesting. But I realized kind of later in school and leaving school that those jobs weren't as readily available as perhaps I thought. So being in the Milwaukee area, we have this huge base of contract manufacturing. We were kind of the machine shop to the world. We were called at one point. So we had a lot of Alice Chalmers and all of these big heavy industry, as well as all of the small shops that came up. And so when I left school, I started doing a lot of contract manufacturing work and designing, and it meant wearing a lot of hats, whether that was doing some sheet metal work or machining, doing the cam for it, everything from the details, plastics and plastic design. But I was missing something. I was missing a little bit of that experience on the OEM, where we were designing and building a product itself. And for me, when I had an opportunity to talk a little bit with Desert Aire, this was some 24 years ago now, I came to realize this is a possibility. Now, I wasn't so excited because I assumed, I suppose, that this was going to be air conditioning. And when we talk about air conditioning, generally we think about it, it's got 4 minimum parts. And those 4 minimum parts are usually, a lot of times that is, all that we see in some of the systems, right? So we've got a compressor that's going to be able to compress gas, and then we're going to have a condenser, and we're going to have an expansion device, we're going to have an evaporator. That's a very basic refrigeration system. And when I went to Desert Aire, I realized that's not what we were doing, right? This is something completely different. We've got many more valves to control, many more different aspects of things we'll get into in a little bit. But the idea was, to me, it just is kind of interesting to be kind of in this niche portion of mechanical engineering and knowing something that not a lot of other people know. So even though, it's maybe not as glamorous at times from the outside, knowing that kind of unique system is really, that was what interested me the most. And that at Desert Aire, we do some of the most interesting refrigeration and HVAC systems you'll see. So that's what got me interested.
I mean, when I think about that visit that I made to the Desert Aire factory several years ago, for me, I think that was one of my first introductions to the complexity of not the refrigeration cycle, but the refrigeration circuitry. And I remember, I think it was you who had this diagram and showing, like all the valves and all the circuits and where hot gas was going and refrigerant was going and the changes that you guys were making. And I was like, oh my God, like that was so over my head. And over those 4 or 5 years, wow, I have learned so much about refrigeration in this world. Out of necessity, right? Just to understand what's going on. And because it is so special, this application and what you guys are trying to do with this equipment, you're really doing a lot of new things, or even if you're not doing new things, it's kind of a souped up engine, so to speak, to really maximize that dehumidification and reheat. So anyway, I have a big appreciation for what you guys are doing. I mean, speaking of that, you guys were one of the first players, right? Who took indoor agriculture and maybe it was indoor cannabis production seriously, right? I mean, you guys came in at a time when growers were struggling with residential and maybe they were lucky enough to be dealing with commercial rooftop units and split systems and off the shelf types of HVAC systems because you know engineers and contractors and manufacturers and growers and everyone didn't quite know what they were getting into and how challenging this was going to be. I've always been curious, why was Desert Aire so interested? Why did you actually take a vested interest in controlled environment agriculture?
Yeah, well, like typical, some of our industry partners, our representatives, some of the engineers that we know in the field, and say, well, for us, it was about 2013, 2014, they started asking us about this and saying, did you know that there's this application out there and it's going to become more popular? And we started to pay attention and look at it. And I think we're very much interested in hearing what they had to say and doing some investigation where others said, well, that's not our thing. The big guys in the industry, the large manufacturers of air conditioning equipment said, well, that's just a niche and we can help support that in some way, but we're not necessarily going to chase a small area. But we deliver niche products in the world of dedicated outdoor air systems and pool room equipment and so on and so forth. And when we realized that some of these loads were definitely a dehumidification load, we knew we had the psychometric understanding as well as some of the base equipment to kind of be uniquely positioned to address this one. And we went forward to do some investigation. And real frankly, when we started to do it, we deep dove in with those industry partners. We started to work on, actually, our first was not a cannabis facility, but it was an indoor lettuce growing facility, basil, microgreens, and so on and so forth. And we learned a lot with that. And we started to expand that out into, the world of cannabis and other crops as well. And what we learned real quickly is that, it was a unique application. It was definitely different. Well, we'll get into in a bit, I'm sure. But in any case, we said, we know psychometrics, we know dehumidification, and that's really what this industry needs.
I mean, how did you figure out that there was a big dehumidification load? I mean, I really want to go back to because still engineers and manufacturers haven't figured this out. How did you guys figure that out so early?
Yeah, that's a great question. For me, it was really deep diving, investigating, what the loads were. So when I gave my first presentation at one cannabis industry event very early in 2015, I will admit that we had done the research. We had deep dove with those industry partners and some growers. We had designed equipment certainly, and we were starting to produce it, but we didn't have a lot in the field when I gave that first presentation. And our methodology about sizing and so on has changed a little bit since then. And certainly we've developed new tools within the units themselves to address it. But back then it was very much, let's go investigate what these loads are, what we believe they are. And so I was using some tools, even going so far as using some of the ACA load calculations and using some of the reference that they have for plants in there, which is
Wow.
very limited. You could imagine, right?
Yeah.
Not a lot there. And just, looking at some of these real basic things that I knew about biology, which is nowhere near what you know now, yeah, and even you knew back then, certainly. But figuring out that, okay, here's the balance between what the air conditioning load is and the dehumidification load, what we call the sensible heat ratio, kind of in our terms,
Hmm.
and realizing that it was a dehumidification load. So yeah, we went out there and we really did the research, and we were fairly confident enough to go to some of that those industry presentations and kind of teach some people about what it was fairly early
Yeah.
on.
I mean, I always appreciated the questions you guys asked. You asked the right questions. You wanted to ask the questions, right? You guys weren't coming in with a lot of ego and a lot of confidence, inexperienced confidence, maybe. You asked questions. You were trying to understand what was going on, and of course, you guys reached out to me, which I always have thought was a smart move
Mhm.
on your part. Um, to ask those questions. And so thank you for that, and recognizing that you guys didn't know everything but wanted to, right? Wanted to understand how to serve this market better. So speaking of that, I mean, what does make indoor plant environments so different from, say, the other applications you guys were coming from, like an indoor pool room?
Yeah, well, it's kind of funny. At one point, someone came to me and we were talking about the application, and they said, "Well, these indoor plant environments are like a data center and a pool room had a baby." And they were trying to say
Yeah, kinda.
we we had all of this sensible load, like a data center where it's the computers and microprocessors that are giving us all this heat, and then we also have this pool application where all the pool is constantly has this evaporation, and it's becoming a dehumidification load. And I chuckled, and I said, "You're right." And then I thought about it a little bit, and I said, "No, that's not right. That's wrong." Because what's unique about the plant environment is things are changing. The plants are growing.
Yeah.
We're doing a photo period and we're doing a dark period. The lights are on or the lights are off, right? And so when that does, the plant, we do that, the plants respond. They've got a different load at different times. And then we talk about the growing cycle. And if we're, say, in a cannabis flower room, we're talking about, they're coming in and they don't have as much dehumidification load. They're not, that latent load doesn't exist there. But the sensible is still there. We still have our lights on, so that's an air conditioning load more than anything else. And during the end of the cycle, now these plants are very large. Leaf area index is up tremendously, and we've got this huge latent load or dehumidification load in the facility. So all these things changing, that was really the key factor. And if you kind of go back, what interested me is I had been doing pools and I had been doing ice rinks and I had been doing, some of these water treatment plants and so on and so forth. And we really, as an industry, we had a pretty good handle on all of this. But we didn't really understand, kind of coming from that small grow in residential, or you said some real small, facilities, and moving it into these larger facilities, how this all impacted, the plants and the lights and so on impacted the loads and how to address them. So, that's really the key factor there. It's really quite different, and it's hard, because It's swinging it from here to there. That lights on to lights off is a tremendously quick change in the loads as we go.
So tell us about the type of equipment that Desert Air provides and how it compares to maybe the other type of air conditioning and dehumidification technology that's available to growers. I tend to think of it in sort of the three broad categories, right? We have sort of a decoupled air conditioning and maybe standalone dehumidifiers. We might have package DX, and then we have, a central plant with chillers and boilers serving air handling units in the centralized system. Can you kind of compare those differences and tell us about what you guys manufacture and develop?
Yeah, that's a good point. No, I think about it in those categories as well. There's some other emerging technologies that are out there, but for right now, really we have either the standalone dehumidification units coupled with an air conditioner, or we have integrated type of systems in one form or fashion. With those standalone dehumidifiers, essentially what we're doing is we're using that for only dehumidification purposes. So, whether it's a small portable unit that's sitting on the floor or some of the larger ones that are ceiling hung and so on, these standalone dehumidification units, what they're going to do is cool the air down to its dew point. And what then happens is the moisture from the air condenses on the surface of the evaporator, right? We call it the evaporator because inside of those tubes, it's evaporating the refrigerant and making the coil surface cold. So as it does that, it's going to wring out the moisture, and now it's cold and fairly dry as it comes off of that coil. And then with a standalone dehumidifier, there's what's called a reheat coil in there. And that's where we took the energy out, the energy from that we took out as we cooled the air down to the dew point, and we're going to put it back into the system. There's three components of that, really, without getting too technical again. The three components really are the amount that we sensibly cooled the air down, the dry bulb temperature, as it's called. We cooled the air down to that temperature. Then as we wrung that moisture out, that's additional energy. It's a lot of additional energy, in fact. If we think about it this way, if we want to go boil a pound of water on a stove, for each degree that we increase the temperature of that pound of water, that's 1 BTU. And as we get that warmer and warmer, we're going to approach 212 degrees Fahrenheit. And then we're going to start to need to boil the water if we want to get it any warmer from that point. And that's a tremendous amount of energy. So for every degree we increase that up to 212, it was that 1 BTU. But when we want to increase that pound of water, that extra BTU from 211 to 212, now it's going to be 970 BTUs for that pound of water. And so, it's a tremendous amount of energy to do that kind of phase change.
A lot of energy, yeah.
Yeah, so we talk about why it's so energy intensive to do dehumidification. That's the phase change is the big energy that we need to do. So in the world of, we're essentially reversing that process in the world of dehumidification. So that's a tremendous amount of energy input. And actually, it's even just a little bit more to do it at our normal temperature of about 70 degrees. It's not 970, and we're reversing the process. It's about 1,050 BTUs at that condition, roughly. So that amount of energy is in the system now too. We're going to reject it. Plus, it takes energy to move energy around. So we've got the compressor energy, the energy that we put into the system to compress this gas and to move the energy around the system. In a standalone dehumidifier, all that energy goes back into that reheat coil, and it's applied to the space as a warm, dry temperature. It can be very warm, in fact. It can be 90 degrees, 95 degrees, even getting up to 100 degrees, depending on the incoming temperature and the load and so on and so forth. So that technology, that standalone dehumidification is, it's interesting. Now we've got this very warm temperature coming out. And in a lot of cases, most cases, in fact, in an indoor plant environment, we need to get rid of that energy out of the space. We brought it, we cooled the energy, we put all that energy, we cooled the air, we put all that energy back in. Now it's very warm. In most cases, we need to get that out. And how we usually do that is with an air conditioner, right? So typical air conditioner, it's going to have one coil that essentially serves the airflow through the space. That's going to be that same type of evaporator coil. And then we're going to have another coil that's outside, the condenser coil in this case. It's not a reheat coil. It's going to reject the energy outside. So it's a remote condenser. And so it essentially rejects. So we got to move the energy essentially twice when we have this standalone. Now, how much we have to do that depends on whether, what the loads are, what the sensible heat ratio is at the space, and how much we need some of that heat and how much we don't want some of that heat going back to the space. So we need to move it twice. How much we need to move is kind of variable, but that's been our kind of traditional way. When it was a very small grow room, we put in air conditioners and we put in dehumidifiers, and we needed to make sure that our air conditioners were sized enough to remove the heat from the lights, some of the other motors within the space, and then also move the heat out that we introduced with the dehumidifiers. Desert Aire doesn't necessarily go down that path. We're really looking for the most energy efficient methods to do this. And so you can imagine not moving this energy twice is really a key factor. So what we do is we look at integrated systems at Desert Aire. Integrated systems mean we can selectively either put that energy back in the air. So let's say it's in the dark period. We can increase the temperature of the air with some of this hot gas that is in this reheat coil, but we can reject a portion of it outside. And so we split the energy and put it where it's needed. And there's a whole bunch of sophistication that goes along with that, where you look at how much load is in the space, how much cooling coil temperature, how low of cooling coil temperature we need, and how much we need to reheat that back up. That integrated system really puts the minimal amount of energy into it and rejects it in the right space so we don't have to remove it again. That's the type of systems. Within that, there's a couple systems we can look at, and that's the direct DX coils, as we described here. But we can also move around some of the energy with water too, which has some other advantages I'm sure we'll talk about in a little bit. But that's the type of systems that we do at Desert Aire. Is we're always looking at the integrated systems, integrated HVAC for the indoor plant environment.
So a couple of the advantages that I heard with an integrated sort of package system is, one, we don't have to move and transfer heat around as much or as far for that matter. And with standalone dehumidifiers, that heat is rejected. All that heat, the heat to cool the air, to dehumidify the air, and then move to transfer the refrigerant around and that energy around, you get these hot spots potentially, right? You get these hot spots in the grow room. And with a package system, right, like what comes out of the unit, what gets discharged from the unit is, what is going to enter the room. You're not going to have these sort of spots where it's warmer and drier, because that's where you have these standalones located. One of the very first cannabis facilities that I visited many years ago, I remember them saying, like, we can't figure out why it's so warm in this corner of the room. Right. And so we walk over there and I'm like, well, there's a vent up there in the ceiling. Right. And so we're like, oh, is that, which direction is it going? And we realize, right, hot air is coming out. And so then we walk outside the room, look up on the top of the ceiling, because, of course, it's in a warehouse. You can see everything. And there's a dehumidifier just sitting right on top and just, pushing warm air down into the room over that corner of the plants. And, you can experience firsthand just by standing next to it. When it comes to package DX systems, I mean, it seems like one of the other potential advantages over maybe the decoupled system is the opportunity to recover that heat. So you are talking about moving energy around, and you sort of shortened, right, the distance at which you have to reject the heat out of the building. But you also have the opportunity, right, to recover that heat directly as potentially an energy savings opportunity, I imagine.
Yeah, and it depends on how you define package too. In the world of like an air-cooled packaged, you can certainly do that, right? So there's a condenser that's reheat condenser inside the equipment and a package condenser coil that's attached. You can also do that with a remote condenser. There could be two condensers, and you might put the AC equipment or the integrated dehumidifier and HVAC inside and have the remote condenser. You can still do that. There's no issue with it. There's advantage to packaged. When we get into questions about reliability, for example, isn't it nice to go to the manufacturer and say, I would like a package from you. I would like to set that on the rooftop, and I don't want to do a lot of the piping going from here to there and deal with the big questions about oil management and refrigerant management. I know the growers, this is probably a little transparent to them, but to run a pipe a couple hundred yards, it can be very difficult. That line has oil in it and it has refrigerant in it. A pressure drop is important. Velocity is important. So these systems that essentially become field built can have, there can be a downside to doing it. There can be an upside as well, but there can be a downside to doing that. So when you talk about an air cooled or water cooled package system, a lot of people prefer that the manufacturer has done all of this quality checks, the R&D associated with it. They're not building up their own system in the field, and it's for very good reason.
Yeah, I mean, and also just there's fewer pieces of equipment to manage and to maintain if you have it more packaged, all those components more packaged together or coming from at least the same provider and manufacturer. Can you explain a little bit? Because I feel like this term gets thrown around a lot, and some people understand it, other people don't. We tend to try to explain what this term means and how it relates to sort of temperature control. And the term I'm talking about is hot gas reheat. What is hot gas reheat?
So that hot gas reheat is that using that hot gas that was absorbed from the system, right? We talked about this great amount of energy that was absorbed during the dehumidification process and the amount that goes in from the compressor and how we need to have that additional energy to move the energy and that amount that we brought the temperature of the air down with. If we use hot gas reheat, what we're doing is we've absorbed this energy. This compressor in the system essentially takes this cool gas that came out of that cooling coil and it compresses it. And when we do that, it increases the temperature, right? So it's that law, right? The ideal gas laws. When we compress this gas, now it's hot. And what we can do with that gas is use it for reheating the air so that when the temperature is lower off of this evaporator coil, now we can flow that through a reheat coil. And if it's a hot gas reheat coil, we're using that compressor energy. So, if you've ever done it before, there may be some growers out there, some contractors out there who's used an air conditioning piece of equipment and then had a reheat coil that might have been electric or steam or water. That's a new source of energy, and that's going to be very expensive in these processes where it's dehumidification. So if we can use this hot gas reheat, that is a beautiful thing, right? And we can reheat. Now, again, like that standalone dehumidifier, what we don't want to do is use all of the hot gas reheat all of the time. That's where the integrated HVAC system can selectively say, I'm going to use some of that energy and reheat it to just the right amount that the environment needs. So everything's in balance. That's the goal of that integrated HVAC equipment. One thing I did want to mention is
Yeah, sure.
a lot of times that it gets confused and someone will say, well, I have hot gas bypass. And hot gas bypass in refrigeration is a completely different thing.
Okay, well, what is hot gas bypass? Because I also hear that terminology. How is it different? Is there anything that's the same?
Other than it's using hot gas. So
Okay, there you go. Fair enough.
So hot gas bypass, essentially, instead of taking the hot gas off the compressor and flowing it through the reheat, this can work in conjunction with hot gas reheat as well. Hot gas bypass will take some of that gas and put it into the evaporator more directly, just downstream of the expansion device. What that does is, you can imagine, we expanded this refrigerant to make it cool in the system. That's what made the evaporator cold. Now, if we push some hot gas into the evaporator, it makes it warm. Well, you're asking, why would I want to do that? Well, two reasons, potentially. Number one, if we're getting down to the point where we're going to freeze the water on the coil, let's say we've got a compressor that's too large for the airflow and everything else that we got going on in the system, we can push a little hot gas in there and reduce the capacity of the evaporator coil so that it's a little bit warmer, and now we don't freeze on it. So it can be a freeze protection type of device. It can be a capacity control device where, okay, we don't want to do quite as much capacity. So we're going to have that a little bit warmer, right? It's not the most efficient methodology, but in conjunction with things like stage compressors or variable speed, or you've heard the terminology of digital compressor, with one of those other technologies, it can be an efficient way to really control the temperature over the evaporator. So hot gas bypass is different. It's taking it from what we call the high side of the system, the high pressure, hot side of the system, and going to bypass it into the low side of the system to maintain the temperature. And so we don't freeze the water on that coil, or we can keep it at a different temperature. So I've heard them intermixed and confused in the past. And so hot gas reheat is about reheating the air. Hot gas bypass is about capacity control.
Interesting. So I want to make sure that I'm clear, because maybe I've been thinking about it incorrectly. So hot gas reheat is taking hot gas from the compressor. It's not taking the hot gas from the evaporator. Part of me always thought, like, right, like the evaporator is absorbing this energy, and then we're diverting it, rather than, right, like through the rest of the circuit, we divert some of that expanded, right, that refrigerant, that hot refrigerant, to the hot gas reheat coil. But it's not coming from the evaporator coil. It's coming directly from the compressor.
That's right. In fact, what comes out of the evaporator coil is actually, it's warmer than when it entered, but it's still relatively cool. What we did inside of that evaporator, we did phase change outside of the evaporator, right? We condensed moisture on that coil. Inside, we're doing the same thing in reverse. We're bringing in liquid, and most of the energy is not coming from the temperature change of that refrigerant. It's coming from the evaporation of the refrigerant, the phase change of the refrigerant. So what goes into the evaporator is essentially a mixture of liquid and a small amount of vapor, because it's expanded through the expansion device. And what comes out, we hope, is 100% vapor, and it's at a still relatively cool temperature. So it might be still 45, 55, 60 degrees coming out of the evaporator. It's not good for reheating the air. So we're going to compress it, increase its energy, and then provide that to that reheat coil.
Got it. I need a vapor compression cycle diagram in front of me while we have this conversation.
I'm not sure your listeners would appreciate a pH chart right in front of us here, but no, that's exactly what we need, and hopefully we're not losing anyone here, because this can be complex, and it's important to at some level understand these items. But it can take a lifetime of learning to understand what's going on. But it's important, if we talk about those who are going to service the equipment and their understanding of this type of thing, this is really important. The complexity of those machines, are not there just for fun. They are fun, but they're not just for fun, right? The sophistication, the complexity comes from the need to provide the most energy efficiency for these particular applications. And then that's why it gets a little bit confusing at times, I guess I'll say.
Yeah, I mean, farmers in general tend to wear many hats, right? And when one of the things I first fell in love with farming when I worked on that mushroom farm in Idaho 25 years ago now was just, I mean, the farmer he was growing the mushrooms. He was, taking care of the equipment. He was doing the accounting. He was selling product. I mean, he was like so many different things. I mean, whatever it was. And it just amazed me how many hats. And now when I think about growers, maybe they don't need to know how to fix their tractor when it breaks down in the field, but they need to know now how to fix their HVAC system or who to call to help them fix their HVAC system, right?
So important.
Yeah.
Absolutely. These machines are running 24/7, 365, and that's not a euphemism. That's not an exaggeration, right? They absolutely are in some form or fashion running that long. And one of the things that we can do to make sure our units stay online is have someone on staff. If the facility's large enough, have a very good maintenance crew that has a refrigeration background, or certainly know you absolutely have a great commercial grade type of contractor who understands your equipment, maybe has gone through training school at the facilities at the manufacturer. Really have someone that you really trust, because you're going to need them at some point or another. The best equipment in the world is still mechanical equipment, and it's going to be serviced at some point, and certainly preventive maintenance as well.
Well, and you were talking about, wanting to work for one of the big threes and right, like combustion engines and things. And, I mean, I think about myself, I'm probably better than maybe a lot of my friends about maintaining, a service schedule and getting my oil changed and getting at least eyes looked at, on my car, on the engine to make sure everything's running okay. But, the same is true for any machine, right? Including HVAC systems, that the more you have eyes on it, the more you maintain it and service it, the better it's going to serve you in the long run.
Absolutely. This is the livelihood for a lot of the growers. So, making sure that we're keeping ahead of any situations, and how I would recommend you do that is certainly do almost a recommissioning on a regular basis, as much as twice a year. Have someone go check the temperatures and pressures again, not just change the filters, but let's look at how the system is operating, even spend the time to compare how it was operating last year at the same time, so we can get ahead of any issues before they start to occur. Because not only are they expensive, but every time that we take a unit offline for unexpectedly, right, that's costing some money. That's costing productivity. It's delaying us. So keeping up with all these things are very important. Going through the details. It can be expensive, and that can be some of the differences between, if we deep dive into integrated systems, we have DX equipment directly, and we have some chilled water systems. And the DX systems, you may have, literally, I've seen hundreds of individual refrigeration systems on a particular site. Could you imagine trying to keep up with PM and service with a couple hundred units on a site? That can be difficult, but it's just necessary.
I mean, is this equipment specialty enough or custom enough that a service technician would need special training or education to service and work on? And I mean, how can growers find a service technician that's qualified to service and work on these equipment?
Yeah, that's a great question. Well, one of the things that I used to look at very closely is if you could find someone who's done a supermarket refrigeration background, for example. That's some of the most complex equipment that's out there, and they certainly have some reheating. Some of them use hot gas or liquid reheating in the applications. There's a remote condenser. These racks are a little bit complex, and there's systems out there on the floor that are complex as well in some aspects. Look at their background. What are the typical work that they do? Certainly, you don't want someone who just does residential AC, and that's their foray. Nothing to, there's nothing to say that they don't know what they're doing, but they might not have been exposed to as much. So go and interview and figure out what the past work that the contractor has been doing and so on. And do they have the idea of the complexity of some of these? As I mentioned, the hot gas bypass, for example, That's often used in some of the supermarket industry. Definitely, as I mentioned, they call it reclaim, hot gas reclaim or hot gas reheat. That's used there as well. And then, yes, finding someone who is if the manufacturer has a certified startup technician's school or a certified training school, sending them, to that particular school. Usually it's not much more than a few days a week, sometimes as much as 2 weeks, and then they're the expert on that piece of equipment. So my recommendation is, go look for people who've worked on complex things before, and then try to urge your provider to go and do it. It can be tough. I know some of the facilities are in remote locations, and
Yep, yep.
you don't have a wide pool of contractors or service techs to pick from, but we have to do our best from that perspective.
Yeah, I'm glad you brought that up because um, definitely location has been a limitation for us on what equipment we have recommended or specified because they're in a remote location or somewhere where they don't have a lot of representation for different types of equipment or specialty equipment or the equipment that would be our first choice to recommend. And so it kind of shortens our list of what we can recommend, but we also want to make sure we don't want to just say use this equipment because we think it's the best equipment, but then they have no way, no one to work on it, right? I mean, we want to pick equipment that's the best for that certain grower, that location, etc. So even if it's not our number one choice, even if it was our number three choice, as long as there was someone there to help them through it, they're going to be in better shape than the top two choices, for example.
Oh, I absolutely agree. And that's
Yeah.
why some of these emerging technologies, we're going to hear more about liquid desiccants, even solid desiccants in some cases. But, one of the obstacles that we have is, who's seen this stuff before, and, are they going to be able to understand, the corrosive nature of lithium bromide or something to that effect, right? So all of these, nuances, we got to get trained up as an industry if we find that we can scale these and reduce their size and cost and so on and so forth. So we'll be talking more about that, but you're absolutely right. You're spot on to say what's sustainable for this particular site. I think that's
Yeah.
a great way to look at it.
Yeah. You know, uh, I want to talk to you about just some of the talk of the town, if I may. We've talked to a lot of people, both our clients and not our clients, who have been dealing with the frustration of failed compressors. And I was kind of hoping you could speak to this a little bit. It's just across the board. It's not manufacturer specific, it's not location specific or grower specific. It just seems to be endemic to this industry right now. And I was just wondering if you could speak to that a little bit. Maybe what lessons have been learned or being learned about this, what growers and their maintenance team can do to avoid these challenges or stay them off a little bit longer. Yeah, I mean, what are your thoughts on that?
Yeah, I think as an industry, as manufacturers, we're always trying to take the data and look at the possibilities and where it is, whether that's something we could help create more robust systems against some of the unusual circumstances or field conditions that are unexpected. That's kind of the start of things, and that's continuously developing. One of the areas it really has to start with as well is, and I think you're doing a great job with it, Nadia, thinking about what's sustainable and what's appropriate for a particular area. So we talked about an air-cooled package system. That's a package that has that integrated, condenser that can reject heat outdoors. Putting that, in Southern California can be a great idea, but it might not be great to put that in a rooftop in Nova Scotia, right? And the reason is because of the cold temperatures and its effect on the refrigeration system as a whole. What happens if you turn that unit off and it's negative 30 degrees Fahrenheit, or, there about there in Celsius as well, right? Um, that has a different effect, and that's something that can have some more wear, and it can have some more potential risk for some of the system components. So as nice as that package system was, maybe that's an area where we want to think more about. It's a split system, as it's called, right? Only the remote condenser, only the condenser and some fans are on that roof, or even better yet, at grade level outside. So we can go look at them, shovel them out in the winter or whatever it may be, because again, we're running 24/7, 365. So it starts there too. We have to be careful about what type of equipment we're applying in what locations, from that perspective too. And then we talk about the preventive maintenance, certainly getting ahead of the issues, and even better than that, continuous commissioning, right? Yes, filter changes are very important, right? Because we're going to load those up at times, in the flower rooms especially. But going forward, can we look at, is this system operating, get ahead of the issue? Compressors, for example, I'll pick on scroll compressors. They're okay with liquid refrigerant, a little bit of liquid refrigerant, but we can't compress liquid. It doesn't work. We break things when we try to compress liquid. So we have to look at and say, do we have a expansion valve problem? If that expansion valve is feeding too much liquid and it goes through and it comes out of the evaporator as liquid, and we can put some safeties in there. There's things like, suction accumulators and that type of thing that's common. But if we put enough liquid in there, that's going to break a compressor. So getting ahead of that problem and saying, nope, we know our expansion device is responding appropriately. That is absolutely critical to things as well. If we can cut that off before it becomes a problem, then we are in much better shape.
Why would liquid be sent back to that compressor?
So if that expansion device, usually in these systems, highly efficient systems have an expansion device that adapts. They're called either thermostatic expansion valves or electronic expansion valves. And they modulate to make sure that what comes out of the evaporator is gas. It's not any liquid, right? And we want to be able to flow as much liquid as possible. So I'm going to do it. I'm going to get into it. Superheat.
Let's do it. Let's do it.
You can cut this part out later if you'd like, but
or they can just fast forward a few seconds.
there you go. But what comes out of that evaporator is superheated gas, and what that means is it's heated above its point where it would flash off to vapor in that line by a certain amount. So if we say we have 10 degrees of superheat or 15 degrees of superheat, what that means is that the gas is 15 degrees warmer than it would be at saturation, at the point it would start to flash off. And that's important because if it's too high, then we are not getting much phase change in that evaporator. It's not getting as cold as we would like it to be, because we're not flowing as much liquid through it and we're not doing as much phase change. But if it's too low, it means that it was close to the saturation point. It was close to liquid. So we have to ride this kind of fine line to some degree. There's definitely a kind of a wider berth that we have there, but at the same time, we don't want it to be liquid, and we do want it to be gas, but we don't want it to be gas at a rate that it would be extremely high superheat. The expansion device, these adjustable devices, it's their job to keep it within a good, efficient, and safe range for that evaporator. So there's sensors on the suction line, the piece coming out of the evaporator, and that expansion device is modulating to be able to maintain that superheat. If that's broken, that's a problem. If it's open too far, it's going to let too much liquid through. We're not going to be able to flash enough off early enough, and it's going to flow through as liquid. So if we look at a compressor, we have to figure out what was the issue. Was there an electrical issue that caused this? Was there a mechanical issue in the form of low superheat, liquid coming back to the compressor? Did liquid get back there because it migrated to the compressor? The liquid will migrate to cold areas. So I mentioned one of the areas where we have the unit, majority of the components outside. We got to be careful about that, because if that sump of that compressor is very, very cold and another area of the system is at all warm, then we can migrate some liquid into the sump of the compressor when it's off. So those are the types of things that we need to be extremely careful about and tackle. If we had a compressor issue, the first thing we should be asking ourselves is why. Yes, compressors do wear out, but that shouldn't happen immediately. And there may be something else in that system that's causing the issue. Let's avoid the repeat issue by finding the root cause.
I mean, is the dynamic nature of these grow rooms a part of the issue with how the expansion valve is responding? I mean, if you, I'm just trying to understand, like, what is so special about indoor plant environments? And we started the conversation with, they're very dynamic. We have photo period, dark period. We have the transition period. We haven't even talked about that yet, right? Where the equipment is trying to catch up with the load, and vice versa. Is some of that dynamic nature sort of pushing this equipment to its limit, or are some of these components unable to respond quick enough to the change in what's happening in the environment that the expansion valve stays open because it was in one state, a one steady state before the dynamic state, created a new load that, oh my God, right? Like it needs to close. Like, is that part of what's going on specifically with this application?
I would say, that's not too unusual for a system at some point to see some changes in loads, no matter what the application. I think one of the items that are in front of us with the indoor plant environments is that this dynamic load through time causes us to potentially size the equipment in a way where we may have more of an issue. If we oversize it tremendously, again, I don't care if it's got a variable speed compressor or if it's got multiple stages. If we oversize it tremendously, then there's this possibility that we're doing some cycling of that compressor and the whole refrigeration system at this part load. And that can provide a little bit more risk, and it can be difficult to keep up. I want to say a lot of this, and I'm not saying that you're wrong by any stretch, Nadia. It's a challenging application, but we really rely on these compressors, and that we put a lot of run hours on these compressors. And there's a lot of systems out there. It really feels at times where, wow, we had another problem, and so on. Again, I don't want to say it's not an issue, but it does get into this impact where we're seeing, oh, this one is down, and then next week that one is down. And if we do have 100 or so units, it can really feel that way quickly. But you're not wrong. There can be some challenges here. I think they have to do a little bit with how we've sized the equipment and its propensity to turn on and off, which is one of the areas that can certainly manufacturers do their best, and they know this happens. But it's an area that can add to some of the issues and add to some of the challenges.
Yeah, and engineers, I mean, we love safety factors, right?
Mm-hmm.
And so, suddenly, you have safety factor on top of safety factor on top of safety factor, and all of a sudden you're 2 times oversized what you needed. And I do think that, especially in the early days of this industry, where so few people knew how to size equipment, that there was probably more safety factor than was necessary, or than were within the sort of limitations of this equipment to perform sustainably and reliably, I guess. So hopefully that's getting better. I mean, are you seeing it improve as the years go on, as this industry? I mean, I wouldn't say it's mature by any means, but we've definitely made big strides in the last 10 years, right? I mean, are you seeing personally, or not personally, but as a company, better selections, better questions, better specifications from design engineers?
I will say yes.
Loaded question.
Was that pause too long? I would say yes. From my personal standpoint, it's moving along, and it's moving along a little bit slowly, but at the same time, experience throughout the industry has given us great perspective on this. So some of the large growers are really taking a scientific look at this. In fact, many growers, I shouldn't say just large growers, many growers are looking at this scientifically. trying to target what they need and trying their darn best to determine what their specific loads are. If they have the bandwidth and the time, and this is a priority for them, they are getting some knowledge and they're sharing it with others, including manufacturers. Manufacturers, we'll certainly talk about in a little bit, have tools now to look at these applications in depth and be able to determine this and share with others. So you're on several committees with me, Nadia, and we're doing our best as an industry to share the knowledge. And that goes to growers, it goes to manufacturers, consultants throughout. So it's getting better. We have a long way to go.
Yeah, agreed. I mean, just to stick with the compressor for just one more minute, something you said earlier, well, I kind of have brought a few things home. One is, earlier you said, that it was like sort of the if indoor pool environments and data centers had a baby, right? Like this is indoor plant environments. One way that I do think indoor plant environments are similar to a data center is that 24/7 operation.
Mm-hmm.
Right? I mean, we are really pushing this equipment hard all year long. And as growers have been, traditionally scared of the outside air and not wanting to use ventilation, maybe to an advantage to help them with dehumidification and cooling in colder months. And we certainly don't need a lot of heating, right? Because we have really well insulated walls and we have all the heat that we're generating in the rooms themselves. I mean, we're forcing these compressors to work hard. Like you said, one time of the year could be like LA, and in the winter it could be like Nova Scotia. And we're asking them to work in all of these environments throughout the year, and maintain the same environment inside those four walls and roof. So that's really tough for them. I mean, if there was one or two pieces of advice to growers and to their service techs on maintaining the duration or the durability of their compressors, like what are one or two things that they could go to every 3 months or every 6 months, to look for and to tune, so to speak, to keep them running as long as possible?
Yeah, like I said, I think one of the things that comes into play is the cycling, whether that again is turning on and off one compressor in a set or the whole system for that matter. What we want to do is check on these occasionally, log the data, that we have and look at it and make sure there will be compressor cycling, but make sure it's not unnecessary compressor cycling on and off, that we are not expecting that compressor to come on for a minute or two, turn off, then come on for a minute or two later. It can be difficult when the loads are low, so that we want to be able to maintain a very perfect condition. But if we've got a minimum turn down, like minimum capacity of that system, that we don't expect too much, don't have it turn on or turn off too rapidly at that minimum load. So look at it, understand what it's doing at those conditions, and there are usually some tools on most manufacturers' equipment to be able to minimize that type of cycling. Obviously, take a look at that compressor superheat, look at the subcooling, make sure there's enough refrigerant in the system, that type of thing. That's something that I think you should be done, once every 3 to 6 months, and reviewing all the systems, as I mentioned. I would think those types of things, and engage the manufacturer if you have questions, right? Get that service tech involved. They're the front line. They're the person who's going to see the equipment. They should know it just about as good as that manufacturer after a period of time. But if there are questions, engage that manufacturer and say, what can we do about this? Is there a tool that you have in the toolbox to be able to make this potentially better? And I think working together, if we do find that there's a unit or a set of units out there that are causing some difficulty, that certainly can be overcome. It takes a team, though.
One thought that comes to my mind is with my car, right? Like the oil that I put in my car in the summer might be different than the oil I put in my car in the winter, a slightly different grade. I mean, would that be true for a refrigerant? I mean, would you want a different charge in the summer than you would in the winter, or do something slightly different? You had talked about, recommissioning your system every 6 months or so. Is that part of it too? Like kind of, I don't know, that liquid that's flowing through there? or
Yeah,
not
no,
necessarily?
we would like to avoid that, right? So in integrated systems, usually we've got a large liquid receiver, and its job is to, in the summertime, that's when the least amount of charge is required out in the system. So then it starts to store liquid refrigerant in this receiver. And then in the wintertime, more is required out in the system. So that's where less is in that system. And good systems have that capability and shouldn't require that kind of personal attention on a seasonal basis. Certainly, you can take a look at it, and if your system is not designed, with that liquid receiver in it, then you're going to have more challenges, and that can become an issue. If it's what we call a critically charged system, it doesn't have that receiver in it, then you're going to have to be extremely careful, and you still are going to have some issues around seasonal pressures and temperatures and so on. So yeah, I would think, having a unit designed for the application is just so important. That gives you your best approach. If, it's an air conditioner that has a reheat coil because they wanted some dehumidification in the summertime, that is not an indoor plant environment integrated HVAC system. That's something else, and you're probably going to run into some issues around those. But that seasonal charge, hopefully we've got that taken care of.
Okay, with the liquid receiver. Now I know what that's there for. Okay, excellent.
So by the time we're done, you're going to go ahead and design your own, right?
I know. Well, that's what I'm getting at here. So no, I'm kidding.
That was the first half of our interview with Craig Burg of Desert Aire. Join us next week to hear the rest of the conversation for his special episode of What Plants Crave from STEM with Dr. Nadia Saba. Thank you for growing with us.